Welcome back. So this is going to be chapter 4. I made a critical failure today where I ended up recording the entire chapter only to find that, in fact, it wasn't recorded. So I'm not doing that again. This time I'm going to probably break this lecture into at least two videos, and that way I can be relatively safe to think I'm not talking to myself for no reason. So this chapter here now is the first one in the design, really in the design section. And so we're talking here about getting requirements. And it is kind of a survey of, well, it introduces a couple of other ideas along the way, which we'll be exploring in the next few chapters. So there'll be quite something going on here. So let's just go and start looking at what we're going to talk about. So we're now in the systems analysis phase. And so we're going to start by talking basically about joint application development and rapid application development. These are two sort of overarching methodologies to getting requirements. And actually, honestly, they kind of evolved to become agile. And that's sort of the last sentence there, or last part of that bullet. We also got to start looking at some diagrams. We look at functional decomposition diagrams. It's one of the first set. I mean, I know you guys did fish bones, but there were some other things coming up after this. So it's sort of the introduction. Mostly, I'm pretty sure most of you know what an FDD is, even if you haven't really called them that, because your standard breakdown structure diagram is basically a functional decomposition diagram. So you'll see it and you'll go, oh, that's what that is. So anyway, there's also a whole suite of diagrams and language, and that's called the Unified Modeling Language. We have a much bigger chapter on that, chapter 6, I think, but it's introduced here. We're going to have basically a discussion about getting system requirements. Rather than just getting a whole bunch in one big bucket, we can actually ask for them grouped by outputs, inputs, processes, performances, and controls. And that's pretty cool. And actually, I try to use that myself in my corporate setting. At that point, we'll probably stop this particular video. And then the next one will start by explaining the concept of scalability, talking about some fact-finding techniques, and total cost of ownership, how to do an interview, and then ultimately, let's talk about documentation. So I think, honestly, the input-output processes, performance, and controls, that's a good time to stop. So we're in this phase now of systems analysis. And I kind of want to get the idea here. What we're doing is we're getting requirements. And some of these are going to be written requirements. Some of them are going to be diagrams. We're trying to basically get the idea of what is our project, what is our, not project, our product, what is our product. And then from this phase, we'll be, like, let me try to say it again. If this phase is successful, it will reduce the risk of the other phases not being successful. We need to know what is actually required of us. So there's basically a fact-finding techniques to basically go and get the requirements. And a lot of times we are using graphical stuff. Not always, but a lot of times we're trying to represent the information graphically. So here's sort of an example, a nice little diagram here. So this chapter is about requirements modeling. And then the next chapter is about data and process modeling, and the next chapter is about object modeling. Now, all these guys work in concept together, and then when we're finished, we're not out of the phase yet. We got one more thing to do, and that is work on how exactly are we going to build this system? What's the development strategy? And so this is pretty well the next few video lectures. So in order to do this, you have to have both strong analytical and interpersonal skills. As I've said in other places, a systems analyst has got strong skills to break down a problem, but then if you're the only one that understands it, you're not going to be very successful. So what needs to happen is you need to be able to communicate that problem. Also, by the way, you're probably not going to get a good understanding of the problem unless you are able to communicate with others. This interpersonal skill is very, very important, and I appreciate that introverts will run and hide now for this. But some of the best people, by the way, for some of this are introverts if you're really good at listening. So there's a place for everybody there. So to get the sort of interpersonal skills, we actually have a few team-based techniques. We have JAD, RAD, and then basically Agile. And the whole point here, in joint application development, we actually bring in people, like normal humans, in the design process. And then in theory, they're released and they're not around for the implementation and then the rollout. Whoops. But in rapid application development, what we're doing there is we're doing a smaller release. So it's like a system development lifecycle shrunk down for a tinier scope, and then we just keep releasing over and over and over again. Like, so a new product comes out every time, or a new piece of the product. So what I would say, for example, if this was D2L, we would be having one release would be perhaps getting the Dropbox functionality worked out. Another release would then have the discussions, and another release would have the grading. A bunch of little micro SDLCs running together, and then not together, sorry, one after another after another. This honestly kind of evolves to become agile, and you'll see a lot of agile methodology is basically a souped up RAD. So here's joint application development. They sort of again have a discussion here. The key here is that lots of people are involved in the very, very beginning, and so here they kind of got a list of people. And notice you got the project leader, the JAD project leader. It doesn't have to be the project manager. It's just whoever's leading the JAD initiative. Top management, managers, and users. Now, at this point, we're not even sure if any of these people can actually turn on a computer. The technical people are right there, right? So this is where you are, basically, in the systems analysis or other IT people. And then someone that's actually recording it. So they'll get together. They'll have a kickoff. They'll probably, have something like this, basically a standard sort of agenda, and that's how that meeting will progress. Now, the disadvantages, as you might imagine, let's go back for a second, is that all of these people have jobs, and they're not doing that job while they're working with us on the team. So this becomes pretty expensive than just the traditional methods. But the reason that this is good is that the traditional methods were prone for failure. So this actually reduces some of the failure from risk anyway, of failure. It's also, the more people you get, the more complicated it gets. But the advantage is that you get to have people in right away. No more do you have to basically give some requirements to somebody and they go off into a closet and come out 6 months later with a program that nobody wants, right? So now what happens is that people are right there and they're working with you, getting a more accurate view of the requirements, a better understanding of the actual goals and even the business. And also, you're working with these people now. So there's, from all perspectives, there's a stronger commitment to get for this to be successful. Now, RAD is just like JAD, except it's sort of a micro version of it. So let's just, I think we can go straight to the picture. So what's happening here is that you quickly get the requirements and then design, construct, keep going, and then bang, release. So what happens here is that instead of doing the entirety of D2L, for example, from scratch, we would do a part of it. We would basically do the Dropbox. There'd be some kind of requirement there about students should be able to upload their homework. So it's like, okay, what would that look like? Let's build it. What do you guys think? Looks good. Release. Now we come back up and say, excuse me, we come back up and say, students should be able to discuss with each other stuff and discussions. We design, construct, keep doing that for a little bit, and then release, cut over. Okay. So it can cut time and expense because, by the way, people can now actually start using bits of your system too. So that's kind of cool. The disadvantage ultimately, though, is that you are kind of doing it piecemeal. So there is a possibility that that you don't necessarily know what the entirety of the thing is because you're releasing a piece of it at a time. And that could mean, by the way, that one piece, when it gets released, might not even fit into a piece, let's say 3 or 4 down. I kind of liken it to sort of Frankenstein. Like I have a friend of mine, Rick Kruger, and we saw this happen where one group kind of released the hand, and another group released the foot and the leg, and all of a sudden this thing doesn't actually fit together. So it's got its weaknesses. All right. Agile is what RAD and kind of evolved to. And there are a bunch of different agile methodologies, but again, it's like an incremental step, and developers and users are all basically working much closer together. It's sort of a continuous release sort of strategy. So here you've got one of the agile methodologies, which is Scrum. Now, I don't know about the whole pigs and chickens things. I know that you're going to be asked that, I'm sure, in the quizzes and in your homework. But what I want you to sort of appreciate is that Scrum is a methodology that's got a product owner. There's somebody who's responsible for the product that you're building or maintaining, by the way, because Scrum continues through the maintenance. You have the facilitator, which is basically the Scrum Master. When you see advertisements out there for the Scrum Master, that's what the facilitator is. And then the actual development team. So these are basically the people running sort of the show. And then you have a tighter integration with users and stakeholders. There's definitely guidelines to this, and I would suggest you look these up. The whole, for future. Agile, by the way, you might also want to Google something called Agile Manifesto, because that's got a neat take on it. It's basically the beginnings of the Agile movement stored on a one-page website. So the advantage is that it's flexible, right? A lot of times you don't really know all the requirements going in. This gets you building as you go. But the disadvantage, at least one of the major ones, is lack of structure. So anyway, read those over. But Agile is basically the way that a lot of companies are doing their stuff now. The romance hasn't finished yet. All right. So there's some sort of methodologies, and now we're going to start looking at some tools, some modeling tools. And by that, you might want to think of them as diagrams, at least at this point. So here we are, systems analysts. What we're doing is we're trying to basically do some fact-finding, take what we learned and put them into models. Sometimes it's just literally just typing up stuff, but lots of times it's actually pictures, and that's what this is about. This is a functional decomposition diagram. So as I said, when you look at it, it's pretty obvious to read. You might want to imagine, by the way, let's go back to D2L for a second. If I did D2L as a functional decomposition diagram, I would have D2L as one box, and then materials was another box, communication was another box, assessment is another box, and resources is another box. And then under assessment, I would have a box for each one of these. Right? That would be sort of an interesting way to break down or do a functional decomposition diagram on D2L. In this case, they've basically taken library management and broken it up. And then they've taken library operations and broken it up. And book management and broken it up. Doesn't mean that these guys don't break down. They're just showing you sort of one lineage. So it's very much like a family tree, except there's only one parent for each child. Another one that they got here is BPM, which is business process modeling. So this is another picture. Now they've given you sort of one example there, but I want to sort of show you another one. And I've got out here in our content section for this chapter, which is not that one yet. This chapter, let's scroll down, and it's probably going to be right there. I've got something called process diagram. And if you click on that, this is made in BizAggie. You can probably see that right there. BizAggie, if you ever want to learn BPM and you don't want to pay for it, then they've actually, they've got this product which you can download, but they also have some video tutorials that kind of explain a lot of the background stuff. So it's kind of interesting. In this case, what I want you to see is you've got some process. So this is called a patching process. So if you don't know what this is, I'll just simply say that when you make a change to a code, to a program, let's say in production, you usually don't log on to production and make the change to the program. Typically, you put your code into a sort of a bundle and it gets released, it gets patched. And a lot of times, the person that patches it isn't the person that wrote it. So here what they've got is how are we patching it to this system? And there's like basically 3 entities, if you want, involved. 2 of these are individuals, and then you've got basically a team. And so obviously, if you're going to basically do a patch, the first thing that has to happen, it starts when the patch composer creates the patch. Then they do some other stuff. One of the things they do is they email the approver. And so now control shifts over to here. And so now what's happening is that this guy started taking a break. And what's happening here is this guy reviews it. And if he approves it, an email goes back. Now control shifts back to the Apache Composer. The Apache Composer goes and says, hey, I'm going to create the service request, basically asking for permission for someone to do it. Once he's done, he doesn't apply the patch. This guy applies the patch, takes the results, sends them back to the Apache Composer, and then at this point, some other stuff happens and it ultimately finishes. All right, so that's an example. Each of these things are called swim lanes. So the approver is a swim lane. The patching team is a swim lane. The patching composer is a swim lane. And I just thought that was a slightly better example than this one. But that's a modeling language with images. What we're going to be spending our next time on is a DFD, data flow diagram. This shows how data flows through the system. If you've already basically done a database course, you're probably a little bit tainted for this conversation. I don't want you to think about data as in database, because a data flow diagram could easily exist in like an 18th century office, where, you know, and not even that, by the way, let's just say 1950s or 60s office, where someone basically took an order as a piece of paper, puts it onto somebody's desk in the inbox, leaves. That person's desk, he or she does something, maybe makes it an accounts receivable thing. Then that piece of paper goes into the outbox. Someone else comes, picks up the piece of paper, goes to someone else's desk, puts it on that desk in accounts receivable. Accounts receivable does something, and blah, blah, blah. That's data. That order is data flowing through the system, being transformed to do like an accounts receivable receipt or something like that, and then being perhaps, you know, shot off as a bill, right? I mean, I'm just making this up, but I'm trying to get you the idea that there's no electricity here. It's just basically people doing their jobs. Data flow diagrams are just doing data as it flows through the system. Another set of diagrams, which we'll be talking about in chapter 6, are use case. Use cases are both a diagram and a kind of a structured chart here. So what we're looking at here is the use case of a credit card validation process. So what do you need to know in this credit card validation process? We need to know who are the actors, who are the people involved. It's customer. Notice, by the way, this little diagram here, believe it or not, stick people are actually used for these. So that's an actor. What's the description of it? This is the general description. How do you know, like, what's the successful completion of it? And then what is an alternative way to do it? So an example here, by the way, if you want to exit out of Word, one successful way to exit out of Word is to click on File and then click on Exit. That would be your successful completion. An alternate might be just to go and click on X. And even then, there's spin-offs there. If the document's saved, it's just going to close. If the document's not saved, both of those will generate a pop-up. What are the preconditions? What has to be true before this thing fires off? What's the post conditions? What it has to be true after it's finished? And are there any assumptions? One assumption here, they didn't put any in here, but one assumption could be that you can't validate, the system will be down, let's say on Sunday or something like that. That could be sort of an assumption. So there again, use case. And again, use cases, nothing to do with electricity. This could easily have been something that we would have used in a 19th century office. A sequence diagram is also diagramming basically timings. So this looks like it's almost the same thing, same use case, but it's a different look at it. So what we got here is the customer basically does something, enters a card number, and then control shifts over here. This guy does something, control shifts back, right? And the deal is it's a temporal diagram. What happens first is at the top until eventually you get to whatever happens last. All right, notice that the BPM diagram, it had a sense of time for sure, but this one is totally time. By the way, the book keeps pumping out Visual Analyst or Visible Analyst as their product. I'll remind you that that's what the book does. I mean, we could use Visio, we could use PowerPoint, we could use actually a variety of free UML tools. All right, so we got a bunch of diagrams. Next thing is now let's just see how can we bucket requirements. And I like the way that the book does this. They break it up as output, input, processes, performances, and controls. And so what you want to do is you talk to somebody and say, well, what are the output requirements of, let's say, D2L? And one of the output requirements is that you guys should be able to view your grades. Another output, I believe, is when you guys submit a piece of homework, I think you get an email. Maybe the instructor gets an email. You know, those are kind of output requirements. I know I actually start there on any of my business intelligence applications. I want to basically know, what do you want out of the system? And then what are you going to put into the system? What's the input requirements? And so, you know, students will be able to upload their homework. That's an input requirement. Students, you know, notice even when you upload, there's an ability for you to put a description in there. I don't know what else there is. But anyway, what's going into the system and how is it going in? That's your input examples. Then typically we got processes, right? I mean, it's not a very good system if it takes the input and this shoots it out, right? There's obviously some transformation that actually happens there. And a good example is that you put in your homework, I mark it, and you get a grade. That's basically the output of that system. So we'd have to basically kind of work out what actually happens in there. And then performance would be things like how many, well, these are good ones actually. How many people can access the system at the same time? What are response times? Is this really 24/7 shop? I mean, does it have to be operational the whole time? By the way, that's expensive. So of course the users are going to say it does, but you got to like really hold their feet to the fire and say, does it really? I mean, is it really going to have to be running on like Sunday morning, for example? You know, those kind of things. And then controls is typically login, and the other thing I'd say is backups, right? So basically, it's how secure is the system. And notice even this idea of audit trails. For example, if I gave you 100% and then later on I go back in and take out that 100% and put 50 there, do we want an audit trail for that? So this is where I'm going to stop this particular video because I got screwed last time. And then what we'll do from there is, that's right, then I'll start with scalability after that. So there we go.